Measures of position or relative standing are numbers showing the location of data values relative to the other values in a data set. So they can be used to compare values from different data sets or to compare values within the same data set. The most important concept we're going to talk about in this video is the z-score. We'll also discuss percentiles and quartiles, as well as a new statistical graph called the box plot. The z-score for a value is the number of standard deviations that the value is above or below the mean. So z-scores measure the position of a data value relative to the mean and the standard deviation of the data. When a value is greater than or above the mean, its z-score is positive. And when a value is less than or below the mean, its z-score is negative. To find a z-score, we subtract the mean from the x value and then divide the result by the standard deviation. The notation is different for a sample than for a population. For a sample, the notation is that x bar is the mean and s is the standard deviation. For a population, the mean is mu and the standard deviation is sigma. But both of these formulas do the same thing. We take our data value, which is the x, subtract the mean, and then take that result and divide by the standard deviation. Now we can also use z-scores to define ordinary or usual values and unusual values. So what we call our usual values are ones that have a z-score between -2 and +2. In other words, these values are ones that are within 2 standard deviations of the mean. The empirical rule tells us that approximately 95% of the data values are in this range if we have a bell-shaped distribution. The unusual values are the ones that are outside of that range, so they have a z-score that's less than -2 or that's greater than 2. And again, this is because the empirical rule says that approximately 5% of the data values are on these two ends of the graph. So we have 2.5% on the left end and 2.5% on the right end. Here's an example. If we have a man and a woman who are both tall, and we're trying to figure out which one is relatively taller, we can't just compare their heights because the mean and standard deviation height of men is different than it is for women. So our question is, which one is relatively taller? What we're going to do is find the z-score for each height, and the one whose z-score is greater is the one who is relatively taller. So we're going to use this formula. For Joe, his height is 81 inches, so that's the x value. The mean is 69.1 inches and the standard deviation is 2.8 inches. If we plug those values in, we get a z-score of 4.25. And by the way, the standard for z-scores is to round them to 2 decimal places. For Candace, her height is 76 inches, the mean is 63.7 inches, and the standard deviation is 2.7 inches. So if we plug these numbers into the formula, we get a z-score for her of 4.56. Since Candace has a larger z-score, that means that she's relatively taller, relative to females' heights. Joe and Candace both had z-scores for their heights that were greater than 4. So that would put both of them out on the right end on the z-score scale. We can also look at the actual heights and put those on the same type of graph. So we have the mean in the middle. Notice the mean corresponds to a z-score of 0. And then here we're going up or down by 1 standard deviation. And notice on our z-score scale, that corresponds to these different integer values for the z-score. So if we're below the mean by 1 standard deviation, that gives us a z-score of -1, and so on. So Joe's and Candace's heights would both be out on the right end as far as the heights go, they'd also be out here on the z-score scale.